Today is gonna be a bit shorter, I presume, since technically it's not a full lesson, as the last ones were. And the topic will be a basic setup on your PC for building .NET at all, and I'm gonna talk a bit about IDEs on the example of Visual Studio specifically, but the general info should apply to all modern IDEs, regardless of what you choose. What you see right now is a fresh Windows sandbox, so this is pretty bare bones. There are no tools yet for development. Well, except maybe the editor, which we'll see in a bit. First, let me just... Oh god, yeah, don't care. .NET SDK. And we can just go to the download. And I'm gonna get the .NET SDK. Now this is an important part. I'm downloading the SDK, not the runtime. Go to all .NET downloads, specifically .NET 9.0, that's the newest version out now. You can get the SDKs, the software development kits, or you can get the runtimes. The runtime is what you would need to just run existing .NET programs. Though technically you can also ship them out with an included runtime, but generally you can have a runtime on your PC and that allows you to run .NET programs. For example, programs written in C#. The SDK is something that allows you to run those programs and create them. It includes other tools like the compiler, most importantly. And yeah, you can see some interesting stuff down here, like with this runtime, we will be able to use C# 13, whereas with .NET Framework, we would be limited to just 7.3. Yeah, let's just go back to the basic site, the one you probably land on when you check out the first time what you want to get. I'm just gonna download the 64-bit one for Windows. And I'm gonna install this, and it's pretty straightforward. Installing .NET, even the SDK, is thankfully pretty harmless nowadays. The .NET Framework was a bit of an issue in the past. You often had to restart your PC, probably because it's so integrated. If I look for Windows features, there we go. Okay, that will take a bit to load, I guess. Let's put that on the side. You will see that the .NET Framework is a Windows feature. So that's why for .NET Framework, you don't actually need a runtime. Or you don't need to specifically install the runtime, at least not on Windows. And it doesn't show. Okay, let's just wait a bit longer. Installation was successful. We now have the SDK, we have the runtime. Actually, we have 3 different types of runtime, but that doesn't matter to us right now. These two in the top, those are what we care about. I'm gonna be close. And that's all we need to be able to create a C# program. I'm not kidding, that's it, literally. It's not comfortable, but you can do it, that's the point. Let's just make a new folder code here. And I'm creating simple program. Fresh settings, file name extensions. I want to keep the extensions like that. Program.cs for C#. This is just a normal text file. We just call it .cs. If you didn't know, file endings don't really have a specific meaning. They're more a suggestion. They a hint to a certain program that this file is probably something you can deal with. So certain programs expect certain file endings, but it's just part of the name, and it's not inherently a different kind of data just because I rename it. And just because it has a certain ending doesn't mean it is that type of file. I can call this PDF if I want to, doesn't make it a PDF file. And I certainly can't open it as a PDF file, but we're using C# code, and the common ending there is CS, C#. And I can just open that with simple Notepad, and we'll just do that as the standard. And if you're working on different OS, you can use any other tool you have available. I mean, in theory, you could do everything here in command line, right? Just echo the output or use a pipe to write it back. If you're on Linux, you can certainly use the terminal, use Vim or Emacs or whatever you like. Certainly better feature-rich environment than just the Windows Notepad, the default one. Anyway, writing a simple program. Let's say using system. Let's just do the very basic program you've seen a couple of times already. Call a public class program, whatever. And public static void main. And we do console.write line. Hello, Twitch. I'm gonna add a second command here that you haven't seen before. Read key. Read key has an optional parameter, a boolean, that I can use. I'm gonna leave that out for now, and it has a return value that we're also gonna ignore for now. This command does as it says, it reads the key. Specifically, we're gonna create a console application. So something that runs in your command line, a PowerShell, terminal, whatever phrase you prefer. And that means you can intercept keyboard input. If you type something on your keyboard, if you press a button, we can react to that. And just as console.writeLine is meant for outputting something on the console, on that terminal, console read key is one command you can use to intercept key presses while in the terminal. This line will simply output something to read on the console, and this line will pause the entire program until you press a key. And then it will return in our code details about what key we pressed on the keyboard. We don't really care about the key itself. In this case, it's simply a way to halt our program, to pause it in the state where it has just output our text. So we can actually see the text appear, and then we have to confirm with any key to end the program. It's just a convenient way to pause the entire thing. You will see in a moment why. Or maybe not in a moment, we have to talk about a few things first. Yeah, this is a very basic program. You can save that, and we can compile this now. But just compiling a program has a lot of gotchas. There's a question of, do we only compile this one file? And what do we compile with? And towards what end? And what settings do we use for the compilation itself? There are a lot of different ways you can try to interpret C# code. A lot of different approaches for how do we evaluate this text, which it's just text that has a special meaning that we know as programmers. And the compiler would know if we choose one. But to give it some context, we have first of all the compiler itself that we use, or in our case the SDK, which comes with the compiler and a bunch of other tools, which gives it a lot of limitations what we can do with this already. But there are still settings we can choose from, even if we're limited to, that sounds kind of wrong, we're not exactly limited. We still have a lot of options, but even if we limit ourselves to just the .NET 9 SDK, we still have a lot of options for how we want to compile this. I mentioned earlier I want to do this as a console application, something that can be seen inside a terminal. Command line interface. We could also program a UI program, which is fundamentally different because it's not run in a console, but it's actually a window, something you can see in a graphical user interface, which is a big difference. Console applications, something with a command line, like this thing, if you know it, is very different from having an actual application like the browser here, which I can click with the mouse in and have visuals, and graphics and whatnot. Whereas on the console I can just type. And while I do like a nice console interface, I do very much like it. Good old those days. You can draw amazing graphics in a console, you'd be surprised. It works very differently. And so it's a different type of program. You have to decide on first what you make. Is it a console-based application inside a command line tool, like command line interface from Windows in this case? Or is it gonna be a UI application with windows and buttons and whatnot? Or you could also make a web application, in which case you don't say anything on your end, but someone could connect to your machine and get sent, for example, HTML data for a browser to interpret. Like different type of program, though they also often have a console on this end. But a definitely third kind of program would be a library, and we have to talk about those a bit later. For now, we know we're gonna make a console application. And we have to give that information to the compiler. And to pass on information to a compiler with C#, we will have a special text file that contains a lot of configuration, determining how our program is going to be built. And this type of file is called a project file, because it compiles several different source code files, like my program CS. There could be other files that are all combined into one larger project, and one project is compiled into one program. So everything you do is going to be compiled into a single file, well, not quite single file, but into a single program or a single library, usually. And that altogether is one project, which we have one configuration file for. The file ending is usually project, PROJ, and for C# we would have a CS project. Could also have something like VB for Visual Basic project, but yeah, CS project, that's what we are gonna do. Yes. We're also just editing this with a notepad, just because we're gonna do the absolute minimum we can right now. So, project files. That touches upon a larger topic called MS Build, which we will have to cover at some point. I'm not sure where best to put it in the lesson plan. Still haven't figured that out. It is slightly daunting. I myself am a beginner of sorts in MS Build. I won't dare claim be an advanced user of it. There's too much in MS Build you still have to figure out, even when I try to explain the basics to you. So I'm not going to explain much about this now. The good news is that you don't need to understand it yet, because later on you will see that the IDEs, and in general most modern tools for programming, will have built-in features to create these files for you and even provide you with easy buttons and simple UI to set all the settings up. So you don't have to write this out yourself and remember how everything is called. I'm gonna just do it now to show you that it can be done. But this is not how you would do it in your actual programming projects later on. So first, MS Build is fundamentally built on XML files. XML, I'm not going to explain XML. Extended Markup Language? Was the X for extended? I hope so. Expression? No, extended. Oh, whatever. XML. Look it up. It's pretty simple actually. There aren't many rules. You have to be just a bit careful with a few special characters. But this project file is an XML file, as are all MS Build files. And we start with the root node called project. And we have to add an attribute, SDK, which was... now I have to think about it. Was it... Something SDK.NET? Was it runtime? Was it framework? Okay, honestly, I'm gonna look this up now. 'Cause I'm afraid I do not remember. Good sign. Microsoft. Okay. It's Microsoft.sdk. And I don't type? What can I type? Microsoft.sdk.net. No, I have to... Let me just make double sure that I don't mix it up. SDK... I mix it up. It was .NET SDK. See, you can do it. I can do it too. I just need to remember how it was. I think it was case insensitive in that case, so I can leave it. Oh no, let's make it case sensitive just in case I mess something more up. Okay, so this is the basic structure. Oh, by the way, this is the structure you would use for .NET. .NET Framework is a lot more complex. With .NET, we got the new SDK style project files, which are very easy. Like, the default setup does most of the things you need. And honestly, all we're gonna add now is to one property group, if it would let me type, please. Thank you. Property group. This is a special type of node for MS Build. Like, property group is entire concept for MS Build. And we're gonna add 2 nodes for the property group. One was output type, I think. I'm gonna double check once I'm done. And we're gonna build an executable. And we want to specify the target framework. And we're gonna use .NET 9. Yeah, that should be it. Target framework. Like that. You know, let's just try it. And with that we have a CS project file. Didn't I set... Did set the checkbox. Okay, now it updated. Okay. Now I'm gonna use PowerShell. I prefer PowerShell over the command line usually. And because we installed the SDK earlier, we now have a tool on our system that we can just call .NET. And that allows us to do a lot of crazy things. Let's just, for now, SDKs, I think that was it. Yeah, you can see we have the SDK installed, 9.0.200. But since we're in our directory now, I can just call .NET build. I should probably also add the program.cs project file as an argument, to let it know that we are targeting specifically that project. But since it's the only thing in our directory right now, we can just leave it at .NET build. And because this is the first time I've run it on this machine, I just installed it after all, I get this nice message in the beginning. Were to call it a second time, you don't get the entire message a second time. And yeah, you saw a few things pop up in between and then disappear, and in the end, build succeeded. Okay, that's good. And what that did is create 2 directories. We have the obj, objects, and bin, binaries. The objects you shouldn't really care about. Those are intermediate steps done by the compiling process. These files are gonna be kept around to speed up the further compiling. Like, they can be reused. So the object folder is only to help the compiler. We can remove it. Can remove it and everything is fine. Next time we compile it, we'll just recreate the folder. But it's best you leave it in most cases just to speed up compilation. It's like a cache, or you can treat it like a cache at least. So sometimes you have to actually remove the directory because some old references weren't cleared up correctly and that messes up your build. So keep it as long as everything works. If you're having issues, for example, if you play around with a lot of nuggets and you have several libraries interacting with each other, and sometimes it's best to just delete the entire directory and build fresh. Reset your cache, so to speak. The directory you should be interested in is binaries, because this is where the output of the build is placed, by default at least. Like, these folders, these are the defaults. You can change them with settings, that's totally possible. I don't see a reason why. Like, this is what I'm used to, this is what I'm always using. And that's the default everywhere. But you might have different requirements, so you can change it technically. Let's have a look in bin. Right now, because of these settings, we have a couple of subdirectories, which are created depending on the arguments are used for the build. Right now, we're making a debug build. Roughly, you can choose between a debug build and a release build, though those are just some default names that make it easy to distinguish. It's just a collection of default settings. Debug is usually intended to just compile your program, but in a way that makes it easy for you to test the code and to check if everything works and to figure out issues easier. Release is the other general type of compilation where you want the compiler to optimize your code as well. So a lot of statements that are in your code that you write can get dropped because they're not needed on the customer system. You just need them for yourself while debugging. Like some additional outputs, for example, to see that the program is reaching a certain step or what values it sees, and maybe some additional functions to make life easier. Those would be put into the debug build, but they should not flow into the final product and therefore are filtered out by the release build. Plus a lot of compile optimizations that make your code a bit faster and more efficient. Those are usually reserved for release because the compiler has to work more for that. And you don't want to do that on every build. That also means that you lose a lot of the flexibility when debugging. Debugging is usually reserved for, I want to step exactly through my code step by step. I want to see what it does according to my instructions, according to the code I wrote. And when you optimize your code, the compiler changes what you've wrote to make the compilation, to make the finished product better. We might have to talk about that another time. And in this debug configuration, we're right now targeting .NET. You can also build for several frameworks in one go. That is possible, but we only gave it the instruction for .NET 9. And finally, we have a bunch of files in here. That's the output of our compilation. And you don't really have to think too much about these files. The only one we really care about is this executable, which I'm gonna run now. Ta-da! That's our console application that we wrote. It says hello Twitch, and right now it's waiting for me to press any button. It's blinking right now because it's waiting for an input. We are at the console.read key. If I go back, we are currently stuck in this line. The program is waiting for us to press any key, and as long as we don't press it, it will stay in this line and this instruction. And once I press the key, it will continue to the next instruction, which just means the program ends. So if I press a button here, the console closes. And that's why we put in the instruction in the first place. If I didn't, you would just see the console suddenly appear and quickly disappear, and you wouldn't know if anything really happened. So there's a way around that. Let's delete this line and compile again. It will replace the executable. You can see the date modifier changed. You might also see that it only changed it for these 3 files and it left the JSON files as they were. Again, don't think about them, doesn't matter. Only now, you only saw it blink for a short moment and then it was gone. So in case of programs like that, we can just call them through a command line tool, and then you will see the output as it was during execution. And even though the program closed and we're able to call the program again, you see the previous output. So yeah, that's why I left the read key in there. And that's everything you need to develop a C# program, in theory. Just some text editor and the SDK. which is available for other OSs as well, of course. Or at least I think it should be. Look, I'm not going to check which OSs are compatible with .NET SDK. It should be available on other systems though. Linux, Mac, whatever. With that, we're gonna leave for the manual compilation step. I'm just gonna close the sandbox. And we're gonna start fresh. Alright, should see it. Yeah, there it is. So, again, fresh sandbox. .NET is gone. Ooh, something. Oh. Interesting. Didn't have that appear before. And the start button doesn't work yet. That works. Ah, now it works. PowerShell. Let's just see. .NET. It should not recognize the .NET command. Nope. So fresh installation, .NET doesn't exist in this world. Just gonna open the browser. Yeah, whatever. Don't really care. Default browser and the default SDK. And let's go to Studio. Let's not do that. How can I change the language here? Do I just use EN? Does that work? Yeah, okay, cool. Now you can actually read what I'm doing here. So, Visual Studio is an IDE, an integrated development environment. I think that's right. And Visual Studio is the one I use professionally and private. It's just, I'm used to it, so I'm gonna keep using it. I'm gonna keep using what I'm most comfortable with. Doesn't mean that it's the best one. It is, I think, a good one. It has a lot of features you want, and it's pretty easy to use in the beginning. I personally have to add a couple of extensions to make it really useful for me personally, but there are certainly other IDEs out there that you can use that have basically the same feature set. They just look a bit differently, feel a bit differently, so I'm not switching. Though I should probably try at least one more for private use, just in case Visual Studio is off the table at some point. But yeah, so again, Visual Studio, not the best out there, but I think it's a pretty good one. One of the downsides is it's only available for Windows, and I think the Mac version still exists, but not really for Linux. You can develop programs for Linux, but you cannot develop with Visual Studio on Linux. So that's a downside. There are other great IDEs out there. I think Rider should be a pretty good one, which is also free, I think. And I mentioned Rider because the same company that creates Rider also creates a certain extension which I use for Visual Studio, and I think most of the features it adds to Visual Studio are native to Rider. Also, if you... Let me just download this in the background and run this setup, because that will take time anyway. When you look for Visual Studio, there's Visual Studio and there's Visual Studio Code. They sound very similar, but are entirely different programs. So just so you're aware, Visual Studio Code, very different programs. And Visual Studio Code is available on more systems. And okay, so in case you use Visual Studio Community, which is the free version for if you're just a single person and just want to do some programming privately, you can use that. There are other terms where you can use it even for a larger group and professionally or semi-professionally and make money off your programs. Just read the terms, be careful with that. You don't want to mess with Microsoft and licensing. They can afford better lawyers than you can, likely. But yeah, the Community Edition, that's the starting point. And in the default installer, I can just check one of these larger packets, which just group together a set of features you might need. You can also just select them from this list individually. So for us, I can just hit desktop-environment.net and it adds most of the things you need. I'm just gonna remove some that I definitely don't want. Don't need that or that. Definitely not that. Don't need that. Don't need that. Nah, I don't need that either. Let's just install. Yeah, this might take a while. Just close that down because I don't want to have Edge open for longer than I need to. Yeah, whatever. I know my system is supported. Not sure why the sandbox causes that issue. Okay, it's downloading now and it's installing. Other IDEs. Yeah, basically any advanced editor can do a lot of IDE work. Something like Notepad++, very good editor. Using that all the time. It's one of the default programs I add to every new system. You can also do development with that. There's also a lot of features you might need. Yeah, I mentioned earlier, there are a couple of text-based only editors, or not text-based, console-based, terminal-based editors that have surprisingly large number of features that you might not immediately think are available in a pure console application, but they exist. What other big, I mean, for C# development, do they offer that? I can't think of a big IDE right now that is for C# development. I mean, there are a couple of general editors which are more general, which means they have less features for C# specifically. Though, of course, if you're a developer that already has them, and, well, you can switch over. Let me just quickly close the window down. Be right back. Getting dark outside. It's still installing. So yeah, actually, maybe we should talk about why do you want an IDE. As mentioned earlier, setting up project files, much more convenient, since the IDE does most of the work for you, and the most important settings are available through the UI in most IDEs. Also, I don't need to run the .NET commands separately. They're integrated in the IDE with hotkeys and buttons and a lot of other goodies. Syntax highlighting, I just use Notepad, which absolutely works, but it's not a very convenient way to program the full program in there. Syntax highlighting is definitely something I cannot live without anymore. We'll see more of that in a minute, I think. Or maybe a bit longer. It's installing. Debugging, a large topic we actually have to talk about, which is one of the best things modern programming has to offer. Like seriously, I would not be able to work without debuggers. Without the ability to step through my code, there's so much stuff that I would have never figured out. And generally just a large set of additional features that just make coding easier. They even offer features like AI tools integrated into your IDE. Now personally, I hate that. Like personally, I don't want any AI in my programming. I've tried that I think a year ago. Experimented with an AI, see what it can do, what it cannot do. Admittedly, it's been a year and that's quite a long time for AI development, so the current tools are probably much better, but no, I think the general flaws I had seen back then are still applicable. And I just personally, yeah, I code. Like, it's not the code itself, it's more the way people use it sometimes. It's just, anyway. Okay, an account. I'm gonna skip the account. I'm not gonna do that yet. And I'm gonna use the blue one, that's a light theme. Of course, the general look and feel of the tool can be changed. That's true for basically any IDE, large or small. Let's just go without code for now. Yeah, no thanks. I specifically deselected it, and yet it's here. I really don't like that. I really don't like that. I try to get it out of my system whenever I can. Can I actually compile it? Hide that. Hide. Oh yeah, hide. Okay. Will you close it? Let's just start Visual Studio again. I'm gonna continue without the code for now. Okay, so for Visual Studio, you have your menu on the top by default. So just the standard menus for a couple of things, then an adjustable UI toolbar down here, and most of your screen will be taken up by windows you can arrange yourself. Let's create a new project. And then can you see more what we have in the UI? So project, in this case, refers to the same type of project I mentioned earlier, just a collection of files that you combine together in one compilation to one program. And specifically, I want a console application for .NET. So this one applies right now. I can also filter for other things here. But this first one is already the one I need. Gonna continue. Then I'm gonna give it a name. Twitch program, whatever. Can change where we store the code. And this one, solution name. It's gonna be the same as our project name for now. Let's change that. Twitch program, the solution. Oh, whatever. No, that sounds weird. Solution name. Let's be creative. I'm gonna continue. Now, for the language, we've installed .NET 9, so we have the ability to compile for .NET 9. Or we could go for .NET 8, which is also available. You can see a long-term support, standard term support. Right now, the model seems to be the even releases of .NET, always the long-term ones, followed by an odd one, which is a short-term support. This refers to how long Microsoft or .NET or whoever has control at that point will supply support and security patches and general updates to those runtimes. So .NET is the newest one, but it won't be supported as long as .NET 8. But .NET 8 is already a bit older, so depends on what you need. Generally, I tend to do the long-term support ones, because our projects, at least at work, have to rely the test of time, so to speak. That means, unfortunately, we have a lot of legacy code from way too old systems. God, I could tell stories. It's scary sometimes what companies get away with. Anyway, for now, we're gonna do .NET 9 because that allows us to use the newest features. And personally, I don't like to use top-level statements. That's my preference, so I'm gonna turn that off. And we're gonna ignore the AOT, because that's also a topic that you don't need to think about. I mean, it doesn't hurt if you turn it on. You don't really have... For you, it probably won't make a difference. You won't notice anything, at least. Once you're more on the topic, this might become interesting for you. Top-level statements, let's ignore that for now, because that's a feature that was introduced in a newer version, and it allows you to write less code, but that also means you don't learn the code as much. So, and personally, I'm not used to the look and feel of that, and so I don't enough. Right. Because I created the project in Visual Studio, it created already a standard C# file. You see this program, the default program, so to speak, which includes a namespace, a class, this one internal though, a static main method, no public, and a simple output with hello world, the most classic of first programs. This is just our code. I can just type in here. This is our code editor. Oop, that's the wrong hotkey. And you can also see the syntax highlighting in action. See, we have the blues for these keywords. So all native C# keywords. And you have some other colors for our own constructions. So this name is the name of the namespace, which we usually skipped so far. It will become important soon. Switch program, which is just in black. And so are these curly brackets. The class name is a light blue here. What is it like? Yeah, I think that counts as light blue. And you can see right now the main and the right line, which are methods, are this more golden brownish color. And the string hello world is in red. Dark red. There are other colors for other things, and you can change them freely to your liking. Let's see, actually, where was it? Customize? No, that was something else. Let's go to syntax. Let's look general. Color. Editor color scheme, maybe? Where was that? God, I haven't touched that in forever. Once you figure out a good syntax highlighting for yourself, you just don't change it anymore. Now, it should be an option somewhere on customize. Let's just go for code style. Oh yeah, that should be it. Or is it just... Honestly, I'm learning this stuff again right now. The menus didn't look like this the last time I've set it up, so... Okay, that's just general style for everything. Formatting, yeah, that's not... Where's the syntax highlighting? Should be specific to C#. Okay, I'm just gonna see customize anything. Are we not in debug, right? You know what? Forget it. I'm not gonna continue. I'm not gonna waste our time here. So, that syntax highlighting does a lot of things for us. Now let's go to the directory where everything is stored, which I can do with the context menu here. But it's the directory we set up or had filled automatically in the beginning. And in here we have now this directory solution name. That's the name of our solution, not our project, which is the directory below that, Twitch program. And here we have the CS project file. Why is it not shown? There we go. And with, I'm just gonna on and edit with a notepad, like that. So this is the same project file we created earlier with a couple of extras. I'm gonna remove these for now. Nullable is cool, but edit that back in. Other features. Right now you can see this has a red squiggly line below it. And the syntax highlighting is gone. This is not blue anymore, and this is not yellow anymore. And we get some hints on the side, and if I just hover over it, we get an error. These are the same errors you would get when you compile the code. But now you can see it directly in your code before even compiling. I mean, technically there's a compilation going on in the background, but you don't notice it. But yeah, this is a very convenient tool. You can immediately see that something isn't right, and the editor shows you directly where and what. And let's see the potential fixes. Oh yeah, it suggests I forgot to import the system namespace. I'm gonna do that. Problems fixed. Of course, it doesn't always work that easily, but if it's something like forgotten using, the system is pretty good about that. There's more though. Remember, I earlier used the console and then .read key. Well, IDEs have additional tools for helping you out write the code. And I'm not talking about AI, just autocomplete on steroids. Still not AI, though AI exists in these, unfortunately. Sometimes they work, sometimes they don't. But just basic autocomplete that knows this console has a couple of features. Let me display them. These are various fields and methods that are available if I use console. I can just skip through them and look for a specific one. For example, read. You can see the list is skimmed down. There are a couple of read versions. Here's read key. And you even get a full explanation of what it is. This is called IntelliSense. At least in Visual Studio, it's the name for it. I'm gonna save. And again, squiggly line, I forgot to end the command here. So it's red, even without doing anything. I'm gonna save. You can see in the top right, left here, this is the tab, this is the text I have open. You can see a little star sign, asterisk. That's because I didn't save so far. Once I save, it's gone and this code is done. And now I should try to run this code, right? How do I compile? A couple of different options. There are hotkeys, of course. I can go to build, which offers me an option to build solution. I can do the same if I right-click on the Solution Explorer here. Or I can just go to Twitch program and right-click here and build. And that would build the program as it did before. You can see now on the bottom a window appear, which shows you the progress of the build. And then the final report if anything went wrong, how much went wrong, if anything worked. But yeah, it just worked. It compiled, we created a program. Nice. We can now go to the bin folder. It's the same structure as earlier. We have the program file, the CS project file, and the object and bin directory. Same as before, and I can just run this program now. Hello world. Same as before. However, this is an IDE, which allows us to debug code. And that means we can also use this feature up here. Or here. And what that does is it starts the program, it compiles it first, and then starts the program for us. So I don't have to open it myself. Once the compilation is finished, it will automatically start it, and here's Hello World again. And on the right, you can see another window appear, which tells us a couple of interesting facts about our code. How much memory is it using? How long has it been running? Is there anything interesting happening? How much processing time does it need? You can even use some more fancy tools to figure out where and how much resources it needs, which can be interesting, but our little program, of course, doesn't really use anything in resources, so the graph doesn't really show anything. And if I now just press a key and have the program exit, you can actually see a bit of text appear after that as a sort of error report or just final report from the debugger, from the IDE, to tell us what happened. And now I have to press another key to close that as well. So I can leave this out and running it from the debugger, we still give us the console and we can see the original output. Even though we didn't have a console.read key, the process was halted and we can still see the output. So that's convenient. We can do more though. In the window down here, we were earlier at this view, which is the build. We can also select a couple of other views. And one of them is debug. And this one is going to be one of your best friends. All of this is useful, but not to you. Not for a while. Actually, I have to interact with it sometimes, and for the most part you can ignore it. It's very rare that you actually have to look this up to figure out a bug. See, I'm constantly using console.writeLine. That's what I've been using all this time. We can output somewhere other than the console though, and that's debug. Now, something you should pay attention to is the usings at the top. Currently I'm using system. Now I'm using the IDE here to figure out, yep, I want debug, and I just press dot. And all while I press dot, it automatically figured out I need this other namespace as well. I need to automatically add the system.diagnostics using. Without this, my debug wouldn't work. It wouldn't know what that is. I need this specific namespace. Not system itself, but system.diagnostics. Which sounds like it is included in system, but you have to specifically say that out. This is technically a different name. The dot doesn't split this name in part, it's just part of the name itself. But yeah, with the IDE, I just had to select the debug, and now I can use a feature in here, like WriteLine. And looks and feels exactly like the console.writeLine. It even works basically the same. Except the output for debug.writeLine doesn't go to the console, but to the debug output, which is what we see down here. So if I run the program, the console itself will just say hello world, as before. But if we look in the output for the debug, we can see hello Twitch. We can't see the hello world though, because this is not the console. And the special thing about debug is, it is one of the features that get added to your code, to the finished program, when you compile in debug mode, but they will be removed from your code when you compile as release. It's one of these things that are useful to you as the developer, but they shouldn't be in the final code when you put it on their customer systems, since they won't be able to use it anyway. At least not unless they're a developer and hook a debugger onto this or somehow else fetch the debug output. Which no sane person hopefully does. Question mark? So right now, when we compile, it is added. But when we switch our configuration from debug to release, this line will be basically ignored. We can compile, just like before. I use the hotkey right now, by the way. Control B for build. And we do get a completed program. We go back to the bin. We have now a release directory as well. And then again, .NET. And there's our program. And I can still run it. Just blink for a moment. Let's just... Right, Oh, Twitch program, okay. Sorry, my bad. Okay, hello world. It's the right program. It has done the right output. But it is a different program. Let's check the size. This is 145,408. This is 145,408. Same size, okay. Well, that didn't really matter. Too little of a change. I was hoping you can actually see the difference here, but whatever. Why did I go to the wrong one? Ah, whatever. So basically, switching to release will technically hide this output. There are other features we can use to differentiate code that should be part of the official release when you give your program out to the public, or someone else at least, and what code should be included only for yourself when you develop. There's more we can do though when we develop. I mean, there are plenty of other functions we could use here. We're not going to talk about that. We leave everything else as is. The debugger. This is starting a debugger. That's why it's on the menu, debug. That's why we were able to see different stats, how much resources does it use. And we were even able to see individual data values inside our program. We'll have a closer look in the working memory. That will let us look in the stack and the heap and the different data that is stored everywhere. That's only available because we're running a debugger, which is a specialized tool that allows us to interact with our program without using the program directly. It would let us manipulate the running code. It lets us look at the code as it is running in your computer, and it even lets us change values in memory, to a certain degree at least. It's not perfect, but it's pretty darn good. And one common thing to do is setting breakpoints, which I do here just by clicking on the left. Oh, can you also use a hotkey? By default that's F9 in Visual Studio. You can see this is now marked with a red background and just pure white text. You can see the syntax highlighting is gone. And you see the dot on the side. I can add another one down here. Now when I start the program with the debugger, you get this little yellow arrow on the left where our breakpoint is placed, and the background changed to yellow on here as well with a black text. The program is halted. The program isn't running anymore. Right now the program is frozen in place, and we're looking at the exact instruction that the computer would process next. If you remember my very first lessons, when I showed you just the very basic CPU, I just clicked on buttons in the background to advance to the next instruction. We'll look at the next instruction, figure out what it has to do, and then execute that and jump to the next instruction. And for that made-up CPU, it was just me clicking on a button that would advance everything. In a real program, it would happen automatically. With the debugger, we can change that back to only advance when I allow you. I can just say continue and just run your program as if nothing happened. But I can also decide, no, just finish this one instruction and then pause again. So we halt here. Only there's one instruction executed, and now this will let us check, okay, we used more memory here, but that could have other reasons. Anything interesting in the output here for debug? No, nothing happened here. You can look at the call stack, which is the stack. You can see, okay, right now we are in the main method, the first part of the program. And we could also just say, no, let's try that again. Output that again. We move the program counter, or it's sort of like moving the program counter back to the earlier place and say, this is the next instruction you should execute. So we do that again. That's just fine. And then we execute this one, and then the program is finished. If we look at the console output, we have 2 hello worlds, because I jumped back manually to this line to execute it a second time. Let's try a bit more. Public static output. Let's copy this over. Then string name. Interpolated string. like that, with proper syntax highlighting. So you can see this is black now because this is actual normal code, not part of the string. If I remove this $sign in the front, it becomes just a normal string, and this is red as well. Now we're changing this. Output. I just hit a button that I didn't want to. Egal, doesn't matter. Output, and we don't do that with Twitch for now. And when we run this code, let's just let's add a breakpoint here. So we stop before the program stops. So call stack, we're in the main. The output already has hello Twitch. And the console also has hello Twitch. Now let's move the program counter back. And this time let's step into the code. We don't say fulfill this entire instruction. We say, no, this instruction will have more instructions following it. This is a method call. Just step into it, follow it. Now we're in this method. We look at the call stack, we can see the main, and now we're at the output. This is the actual stack I'm always talking about. We have the main methods, that's where we came from. Now we're in output, this method. And on the left, you can see all the variables we currently have in our method. Right now, we have only the variable name, which is a string. On the right, you can see the type is string. You can see on the left the name, which is name. And in the middle, you can see the value that's currently stored on there. You can also go back up here and see the variables that are stored in the main. So this is the table of variables we have in the main method. This is the table of variables we have in output. Remember those tables I always write down? This is just a different order. The type is in the back. For me, it was always in the front, the first one. Now we can go through here. And I can see the name is Twitch. I stepped over the console.write line, and you can see we have a return value from string concat. This interpolated string is basically the same as having just the string hello, comma, and a space, and then concatenated with name. It's a function that merges these two strings into one string for the output. In the background, this is changed to a method called to string.concat. And that method returned hello Twitch, and that was passed onto write line. So all we see in the code is interpolated string. But if you use the debugger, you can see, oh, it's actually calling string.concat. So you know what happened here. Let's go back up here. You can still see the output for now. It will disappear in a bit. What we care more about is the name. Maybe I don't want to output Twitch. I've debugged and I decide, no, Twitch is wrong. This should be world. So I just add the new value and I'm done. You can also do that in here. Hello, Twitch world. So I can actually change values in the running program without having to restart the entire thing. So do this now, and we jump back to the main, and finished. So we have hello Twitch from our first run and hello Twitch world from the second. If we look at the console, I ran through the console.write line twice and once with Twitch world. So those are some of the basics. If you get your hands on an IDE like this, you just have to spend a lot of time with it. Just play around, see what options are there. Visual Studio is one of the nicer ones. I didn't really have to change anything. These are all the defaults that are enabled from the start. Personally, I use a very different setup for everything here. Like the way the windows are arranged and which windows are visible when. That's very much personalized. But this is fine. If you're just new to the game, so to speak, and want to play around with the most IDEs, will have a very simple, useful first view that will cover most your needs. And then you can start from there and play around and adjust as you learn the different features. Let's talk about those features once more on the Solution Explorer here on the right. This window. Just gonna make it a bit bigger because I can, and then make it smaller again. Like that. You see Twitch program is in a tree below the solution name. Let's go to the folder view. We had in the directories, we had solution name as a first directory, and below that we had Twitch program as the second directory, and in there we had our CS project file and our program. And in the top level we had this other file, solutionname.sln. That stands for solution. Solution, I'm just going to open it now, is a collection of mostly projects which are combined together. So if I go to the directory again, right now this solution only has one project called Twitch program. I can add another project though. I can add many projects. And this is going to be a class library, not an executable. This is not going to be a program we can run. This is just code, a library we can call. Library code. Also gonna leave it at .NET 9. Create it. And now we have two projects in here, our Twitch program and library code. Wrong button. Library code, Twitch program. Twitch program looks just like before. CS project, our program file, bin and object. And library code works basically the same. We have CS project, bin and object, and a default class 1 that was added through Visual Studio. And here we can just public static big void. Actually, let's just copy the code from here. We can add our output method right here. And something else you've seen, or maybe not have seen, but just return the code. Once I paste it, it also adds the system diagnostics again, which we needed for our debug. What I did not see was the system appear, because that wasn't needed back then, but we can change that. So if I just have my class like this and add it back in, the computer knows, okay, this output code used the console from system and the debug from system.diagnostics, so just add them automatically. It's one of the many small features, like these little details that you don't really notice, but that make your life so much easier. Right, let's go back to program. We removed the output method, so naturally it doesn't know what to do with output. The method doesn't exist anymore. We have to include it somehow. And that means we have to make our code Twitch program somehow aware of the code and library code. A separate project. These are separate projects that can build independently. I've built library code now, which succeeded. I can also build Twitch program, which will not succeed, because output doesn't exist. Doesn't know what to do with it. I can also now build the entire solution, either here or at the top, build solution. And if we look at the output, you see one failed, one up to date. The one up to date was our library code. We didn't change that, so it didn't need new compilation, so that's efficient. One failed was because of an error in Twitch program, which we also have seen already. So a solution, in the simplest case, is a collection of independent projects that you can just conveniently compile all together. And that can be any kind of project. I can have two different console projects, that's fine. In this case, I chose a library, however, and libraries are meant to be used by other projects, which could be other libraries, which themselves could be used by another library. until at some point they're going to be used by an actual executable, like a console application, like our Twitch program here. So I need to make library code available to Twitch program, and I can do that through the dependencies here in Visual Studio. Just right click on here, add a project reference and library code. That's the UI way to do it. Take a look at the Twitch program CS project file in the background. Check what properties we have right now and which properties will appear once I hit OK. It's not a property, it's an entire item. Item groups are also a basic feature of MS Build. Property groups are like... The way I like to explain it, property groups are like strings. Like simple variables, we have a variable called output type, which has the value exa, target framework, which has the value NET 9.0. While item groups are more like arrays, a bit more. They can contain a large number of values. Right now it contains only this one value, but we can store other values in there as well. So these are like single arrays, item groups are single strings, sorry, properties are like single strings, items are like arrays. Roundabout. It's a bit more complex than that. Anyway, with this we made Twitch program now aware of a library which it can find as a project in this path. And this is a relative path. If you didn't know that, ... just means take my current location, go one folder up. So if we do that, let's go to Twitch program. So take my current location, where the CS project file is located, go one folder up, ... and from there go to library code, and then library code.cs project. And we did all that through UI, so we don't need to specifically find out the path and write that out manually. And now Twitch program is aware of this code. We just have to reference it with the using, and the using should be the namespace of our own code, library code. Which IntelliSense already suggested for us, and now output is available through class 1. We can run our code. It compiled everything it needed and ran it. There's also something else to look out for. When I build Twitch program now, it will also build library code. We made a dependency on Twitch program to library code, which means Twitch program needs library code to work. It needs this code we wrote here. So it will first compile library code and then it will compile Twitch program. If library code doesn't work, Twitch program cannot work. So if I do this, just some nonsense, and try to build, it will have some issues. Cannot compile library code, so it cannot complete the build. Let's correct that. And compile again. One succeeded, one up to date. Let's remove this. So we changed the code. It will need to compile again. One succeeded, one up to date. Let's return this. No thanks. And Twitch. Change this. World. Now both files are changed. And now two have to be compiled and succeeded. I can make a breakpoint in here, of course. So if I debug our program now, we come from main in Twitch program DLL. So our Twitch program project. But now we are in library code and output. But otherwise the debugging works exactly the same. We're in a different project, but that doesn't matter to our debugger. It will treat both as one large code base, so to speak. As far as the code is concerned, this class and this program belong together in one program. The only difference is that this has a different namespace. and there's a separate file now, which is also something we should look at. Library code, just like before, has a debug output built, but here is no executable, because we didn't design library code as an executable. There will only be a library file, a DLL, dynamic linked library. And this is just compiled code to be used by another program, but that cannot run on its own. There's no main method to start. This is just a collection of code that Windows has no idea how to use. That's not an issue. Twitch program knows how to use it. And when we start Twitch program, it will actually look for a DLL called library code, which also has some other properties to identify it, like it has a proper name, a version, and everything else. And that's what you can see in the beginning. It does that with a lot of other libraries as well. You can see here it loaded. These are all standard libraries it needs to run, which came with system, for example, and system diagnostics. And in here, you can see the line where it loaded library code.dll. That's our library that we wrote, which was loaded with all the rest, and all of those libraries, all those DLLs are combined together into one singular program in memory. And from there on, they are treated like one large program, even though it's technically compiled as a separate project, which is treated differently from our Twitch program. It's a larger topic. I don't think it's really complicated, unless you want to make it complicated, which I probably did. So we have solutions, which are groups of projects, and each project is one singular collection of source code files that are combined in one compilation step. So one project compiles all its code into one file, one executable or one DLL. And a solution has many of these projects which are combined together for one program usually. So again, I've mentioned that earlier, you can have multiple executables in one solution. They're all compiled independently. It's just rare to see that. There are special reasons why you might have several executables in one single solution. Oh, what else is there to say? Many IDEs will have integration with source code management, of course. So you can see down here is the tab Git changes, because Visual Studio is by Microsoft, and Microsoft, of course, owns GitHub now for a while. So they have pretty good integration for Git. But not only for GitHub, also for DevOps, which is probably the better integration. Since, actually, how is that? How good is the GitHub integration nowadays? Because DevOps, it's like their Team Foundation server, right? It's the successor to that, or just the rename version? Or is it a separate thing? It's the system they have for longer now. So that integration is pretty decent. GitHub, I don't have used the GitHub connection in Visual Studio yet, but it can do Git. It does it fine. It's not great, but it does the job. And source control is something we need to talk about at some point, but not relevant for now. And yeah, that's how you can develop your system. I have a solution here. You can just open that with Visual Studio. It will take a bit to load up, and it will load all the projects and all the additional data to them. It allows you to make a lot of configuration through UI, and it easily allows you to code through a lot of smaller features that you don't notice until you're missing them again. And if there's something you don't have that you definitely need, you have extensions, which are little plugins or add-ons you can use for Visual Studio. You have to be a bit careful with that. Many add-ons, many very useful add-ons are entirely free, but there are some that have either paid content or entirely paid. So keep an eye on that. don't fall for the tricks. Something I use, productivity power tools. I don't use all of these. I think I don't use most of these, but there are some good ones here. Like if I install that right quickly, just so you can see how extensions work. Okay, so it's installed. I can install more now. Or I'm doing quotation marks with my hand right now, installed. I marked it as to be installed. It has downloaded the stuff, but I have to first close Visual Studio, and then a window will pop up, which handles the actual installation. Yeah, I'm modifying, that's fine. Power Tools is actually a collection of individual extensions. You can turn them off individually. The other big extension, or the biggest extension I use, is called ReSharper from JetBrains, who also make Rider, a different IDE entirely, which I think also works on Linux. Personally, I haven't used Rider yet, but I suspect it's pretty good. Not only because it probably includes all the features that I get from ReSharper that I'm missing in Visual Studio natively. Okay, installation is done. Let's start Visual Studio again. I should have opened the solution, or whatever. I can do that in a moment. Because here I just have a history of the last solutions I used. I can just click on that and it will open it. If I don't have the file ready from the get-go. It's still loading, compiling, and for go to extensions, installed. I have now the entire collection. And I do some cool stuff. Like the ones I use, copy as HTML, quite useful. Fix mixed tabs, not too useful if you have good coding standards in your team. This one is good. Match margin, I use that a lot. Let's see, shrink empty lines. I use that, but I'm not sure if it's needed. Timestamps also very, very useful. And the solution error visualizer. Let me just show you some examples. Let's just say I forget the semicolon here. Close the file. Now I'm in my code here in program. I build it. And it didn't work. Okay, I get an error. And I can go through the error list here and find it pretty quickly. But I can also just have a look in the Solution Explorer on the right. You can see there's a right squiggly line now here. In my solution is an error, anywhere. It's specifically in library code, and in here it's in class 1. So if I hover over it, I get the same error message. So if you have a really large solution with a lot of different errors and lots of different classes, that's very useful. It's not also only for errors, it's also for warnings, which you might not see in your output if you turn them off somehow. This is a hint, I can also do that. So that's one. Then the output, if I just run the code now in debugger. You see in the debugger now there are these timestamps. Those are quite useful if you don't have timestamps in your messages by default. Like if you have a good debug output in actual logging, then you probably have timestamps already. But if you just want to make simple outputs and want to figure out when did what happen, how long did something take, you just look at these timestamps and you're fine. These are the actual time of your system clock, by the way. So at 23 and 45 seconds, it said hello world. That's quite useful. And a couple of other things like shrinking the line here. Not sure if it's clearly visible, but this is slightly smaller. And what else can we... If I double click name on the right, you can see little dots appear. You can see the name is highlighted everywhere now. On the right, you can see dots. scroll bar. And every occasion where there are a lot of really useful little additions. So the power tools are free. I find them very useful. You should probably try them. As for other add-ons, it's up to your discretion. I also use the markup editor, which is somewhere in here. And I use ReSharper, which is not free. Just to be clear, ReSharper actually costs quite a bit. So don't do that if you're just starting. It also makes Visual Studio slower. Like I've some colleagues which don't like to use ReSharper because it makes Visual Studio slower. Just try native Visual Studio or another IDE. Maybe try Rider or maybe Visual Studio Code. But if you don't like Visual Studio, maybe you don't like it because Microsoft. In that case, you should definitely not go for Visual Studio Code. Or you just use the text editor you have and just try directly compiling. That's also a way to learn. Yeah, and that's it. Next time we're gonna start programming again, then in my dev environment, hopefully, if I get the setup right. And we'll have a better look at, well, I'm tempted to say real coding, but more advanced topics. No more language features. See you then.